For years, we have been warned about impending doom from the sun. If pointed in our direction, powerful eruptions of radiation and plasma from our star can strike our planet to supercharge Earth's atmosphere and magnetic field, effectively hitting a global reset button on much of our modern technology. A sufficiently intense bombardment could raise a geomagnetic storm that would push satellites out of orbit, short out submarine cables that suture together the internet, and plunge the world into darkness with massive blackouts from collapsed power grids. But just a few days ago, when one of the strongest solar outbursts in 20 years blasted our planet, we managed to emerge unscathed thanks to years of careful public and private planning. The storm has ebbed, although the solar region that sparked it has since spat out additional monstrous flares, fortunately no longer targeted at Earth because of the sun's spin. But while we've passed our biggest test yet, experts say now is not the time to let down our guard. The question of more cataclysmic solar activity isn't a matter of if, but when. When will the next big solar storm occur? What would happen if another Carrington event-level solar flare occurred today? Would we be ready for it? All this and more will be discussed in today's episode. To better understand the upcoming catastrophe, a brief refresher about the strongest solar storm in 20 years is needed. On May 8th, after ground and space-based telescopes detected multiple explosive outbursts from the sun headed for Earth, the SWPC issued a warning of an imminent severe space weather event. At least 7 of these outbursts, known as coronal mass ejections or CMEs, walloped our planet with billions of tons of solar plasma, an interplanetary punch that left Earth's magnetic field ringing and made the upper atmosphere swell, almost as if bruised. These CMEs were launched into space last week by solar flares from a single massive sunspot, named AR 3664, which is more than 15 times wider than Earth. A majority of these flares were X-class, the most powerful type of surface explosions the sun is capable of producing. The CME bombardment temporarily weakened Earth's protective field, which enabled charged particles from the sun to penetrate deep into the atmosphere and excite molecules of gas. These in turn triggered vibrant, multicolored auroras at latitudes much farther from Earth's polar regions than normal. In the northern hemisphere, auroras lit up the skies as far south as Florida, Mexico, and Puerto Rico, as well as across parts of Europe. Similar light shows were also spotted at equally unusual latitudes in the southern hemisphere. According to NASA officials, the auroral displays that wowed observers around the world 2 weekends ago, including folks as far south as Florida in the U.S. and Ladakh in northern India, may have been among the strongest such light shows since record-keeping began over the past 5 centuries. Scientists at the SWPC had forecast that the storm would be a severe G4 disturbance, the second highest class of geomagnetic storms. However, the disturbance exceeded initial expectations and briefly reached extreme G5 status, at least twice over the weekend, firstly on May 10th and again on May 11th. This is the same category as the infamous Carrington event of 1859 and is the first time Earth has experienced G5 conditions since the Great Halloween storms of 2003. At present, it's difficult to say just how close we came to catastrophe, because many companies, from grid controllers to satellite operators, do not like to reveal information on how a geomagnetic storm affected them. But various scattered reports are already offering some insight into the storm's disruptive effects. Flight trackers showed airlines rerouting planes to avoid Earth's poles, where crews and passengers would have been exposed to worrisome spikes in cosmic radiation from the storm. Transpower, New Zealand's state-owned enterprise running that nation's electric power, said in a statement that it had preemptively switched off some circuits across the country on Saturday or May 11th, and as a result, there was no impact on New Zealand's electricity supply. In Minnesota, the firm Minnesota Power opened capacitor banks to deal with possible effects from the storm. Similar precautions were likely taken at other power grids around the world, too, although the lack of information makes it tremendously difficult to know how effective those measures were. Geomagnetic storms can also play havoc with signals from GPS satellites, and multiple farmers reported issues with GPS-guided farming equipment over the weekend. In South Dakota, one farmer's tractor started driving in circles during the storm, and multiple farmers reported outages on social media. "Our GPS on both the planter and the strip tiller were absolutely bonkers today," one commenter wrote on Reddit. "I saw this post and looked. No GPS," said another. Landmark Implement, a John Deere dealership based in Nebraska and Kansas, texted its customers an advisory to turn off GPS devices on their farming equipment. The base stations were sending out corrections that have been affected by the geomagnetic storm and were causing drastic shifts in the field, the company noted in an online post. The storm posed hazards in space as well. According to NASA, 7 astronauts on the International Space Station were mostly safe from the storm's effects, but did have to take some precautions. As Sandra Jones, a spokesperson for NASA's Johnson Space Center, said, the crew was told to avoid lower shielded areas of the space station out of an abundance of caution. Certain areas provide less protection from radiation, such as the airlock, while other areas, such as crew quarters, provide enhanced protection. The crew was never in any danger, and the energy levels have since decreased. Other satellite operators experienced greater difficulties. One company in the UK, Sen, which streams 4K video from a satellite in low Earth orbit, chose to power down its spacecraft for 4 days to prevent any damage from the storm, such as fried circuit boards or electronic failures. In the words of Marcin Bujar, spacecraft operations lead at Sen, "It was in an idle mode. We just kept the bare minimum on, the flight computer and radio receiver." This prevented the satellite from carrying out some tasks, including planned observations of flooding in South America and wildfires in Canada. "It definitely had an impact," Bujar says. Larger groups of satellites, such as SpaceX's 6,000-strong Starlink mega constellation that beams the internet to Earth from low Earth orbit, were affected too, although the full impact is unknown. Elon Musk, SpaceX's CEO, merely noted on X that the satellites were under a lot of pressure, but holding up so far. Back in February 2022, the company lost 38 freshly launched Starlink satellites after those spacecraft prematurely re-entered Earth's suddenly swollen atmosphere because of excess drag from a geomagnetic storm, but such issues seem to have been avoided this time. Another Starlink launch proceeded as planned over the weekend, successfully deploying 23 satellites into a higher orbit, less susceptible to such effects. Sangeetha Jyothi, a computer scientist at the University of California, Irvine, says the geomagnetic storm does seem to have increased delays in Starlink satellites communicating with the ground, though. "We can see some impact, but it was not disastrous," she says. For ground-based internet infrastructure supplied through submarine cables, the storm was not strong enough to cause any issues, she adds. Atmospheric swelling caused by the solar storm proved especially notable on the Hubble Space Telescope, which, despite orbiting hundreds of kilometers above our planet, still descends slowly earthward because of drag. The storm, according to Jonathan McDowell, an astronomer at the Center for Astrophysics, Harvard and Smithsonian, doubled Hubble's rate of orbital decay to about 80 meters a day instead of 40 meters a day. And that's a big deal. As Claire Andreoli, a spokesperson at NASA's Goddard Space Flight Center, said, Hubble is currently estimated to burn up in Earth's atmosphere in the mid-2030s. Without boosts from other spacecraft, however, further bouts of solar activity could make Hubble's swan song come years earlier, lessening the amount of time that astronomers have with one of the most advanced telescopes ever built. However, overall, our planet seems to have mostly survived its latest solar tirade. Society and civilization as a whole have not come to a premature end. But don't pop the champagne just yet. While big, this storm is not the extent of what we can expect to face in the coming decades, or perhaps much sooner as the Sun heads toward the peak of its 11-year activity cycle in 2025. Measuring the strength of any given geomagnetic storm is difficult because there are many factors at play on Earth and in space, but a crude number can be given. Geomagnetic storm strengths can be expressed in nanoteslas based on measurements of Earth's magnetic field, which has a baseline of -20 nanoteslas. The most powerful recorded geomagnetic storms in history, the Carrington event of 1859 and the New York Railroad storm of 1921, both registered at around -900 nanoteslas, although the former was potentially as high as -1,150 nanoteslas. The May 2024 solar storms reached a peak DST index of -412 nanoteslas on 11th of May. Over the past decade, much has been made of the potential threat of solar storms thanks to work by the SWPC and other organizations. In 2020, the U.S. government passed the Promoting Research and Observations of Space Weather to Improve the Forecasting of Tomorrow (PROSWIFT) Act to develop formal mechanisms to transition space weather research models and capabilities to operations. That has been hugely beneficial to make sure that space weather is treated much more respectfully. We are much more prepared than we were 10 years ago. The outcome, in the US and abroad, has bolstered our space weather forecasts, giving us our best warnings yet on the impending danger from a solar barrage. Last weekend's solar storm shows that this diligent preparatory work has not been in vain. This time around, everything went according to plan. But when a much stronger Carrington-esque storm hits, will we be ready? According to Alexa Halford, an associate chief of the Heliophysics Science Division at NASA's Goddard Space Flight Center, the answer is a cautious affirmative. There's still a lot to learn, but we've had success. Flares occur when electromagnetic radiation erupts from the sun. These bursts often last a few minutes, though they are sometimes longer. They are sometimes associated with coronal mass ejections, which blow out gas material in magnetic fields. But not every solar flare or coronal mass ejection will have an impact on Earth. It depends on both the size of the burst and the direction it's heading. If a solar flare occurs on the far side of the sun, for example, it's unlikely to affect us. Even if it does happen on the near side, the direction of the burst often misses us, as we're quite far away and a relatively small target compared to the sun. This occurred in 2001, for example, when one of the largest solar flares in recorded history exploded into a coronal mass ejection at a speed of about 4.5 million miles per hour. Luckily, it swept by us on its way into space. Technology was relatively simple in 1859 when the Carrington event occurred, but it still had a big impact on telegraph lines. At the time, people had to unplug the wires to stop the sparks erupting from them. But they remained partly functional, thanks to the particles ejected from the flare that struck the current in the lines. They actually had to unplug them, and they still had enough energy and currents to run for a period of time, Halford says. There have been earlier solar flares whose impacts were felt on Earth, of course. A sunstorm that occurred in 993 AD left evidence on tree trunks that archaeologists still use today to date ancient wood materials, such as the brief Viking settlement in the Americas. Another significant solar flare occurred during World War I. It wasn't as large as the Carrington event, but it still confused detection equipment. Technicians believed bombs were dropping when it was actually interference from the flare hitting the magnetosphere, Halford says. A large coronal mass ejection recently struck Earth in March 1989, and the resulting geomagnetic storm caused serious havoc on Earth. The flare knocked out the power grids in Quebec and parts of New England, as the utility company Hydro-Quebec was down for 9 hours. Power transformers even melted due to an overloading of electricity in the grid. The world has become far more dependent on electricity than it was when the Carrington event occurred. If a similarly powerful solar flare that was pointed at Earth, as opposed to away from our planet, where it would not have any direct consequences for our world, were to explode now, it might cause unprecedented damage. For example, a 2013 study from British insurance giant Lloyd's of London estimated that electrical outages from a Carrington-level event might lead to up to $2.6 trillion in lost revenue for the North American power industry alone. The study also found global blackouts up to years long might occur because such an event could simultaneously damage multiple extra high voltage transformers that are difficult to replace. This could in turn result in major disruptions to financial markets, banking, telecommunications, business transactions, emergency and hospital services, the pumping of water and fuel, and food transport. Similarly, a 2017 study in the journal Space Weather found that in the most extreme blackout scenario, impacting 66% of the US population, the daily domestic economic loss could total $41.5 billion plus an additional $7 billion loss via international supply chain disruptions. In contrast, if it only affected extreme northern states, which are home to 8% of the US population, the economic loss per day could reach $6.2 billion, supplemented by an international supply chain loss of $0.8 billion. As a quick note, the study calculated using 2011 US dollars. So, what would happen if another Carrington event-level solar flare occurred today? Could it be a catastrophe? Frankly, maybe things aren't that bad. Either way, there are many kinds of things that we have really learned our lesson from the 1989. For instance, power companies then began building safety measures, such as tripwires, into the electricity grid to stop cascading failure. If power increases too quickly, these tripwires are programmed to switch off so that damage is limited and transformers don't burn out as they did in 1989. Geomagnetic storms can also cause bit flips, surface charging, or internal charging to satellites orbiting our planet. All things that occurred this October when a solar flare produced a coronal mass ejection and a geomagnetic storm that hit Earth. Satellites are particularly susceptible because they don't benefit from the relative protection of our atmosphere. But most of the satellites launched in the past 2 decades have been built robustly enough that they are resistant to overcharging. The bit flips occur when ionized particles from the solar outbursts switch the function of memory bits. This can cause big problems for GPS satellites, which affect everything from navigation to precision drilling. Even banking relies on GPS satellite to dictate the timing of transactions. That kind of failure would really hurt the economy. It's important and definitely something we should be worried about. While satellites are now built more robustly, she adds that it's unlikely a storm would take out enough GPS satellites to cause many larger problems, though. These problems can also sometimes be easily fixed by power cycling or simply by restarting the affected device. On the other hand, note that not all impacts of a large solar flare would necessarily be negative. When these events occur, they thicken the density of Earth's upper atmosphere. In effect, the atmosphere rises in altitude for a short period. This can impact the orbits of satellites, potentially causing problems, but it can also affect the orbits of space debris floating around up there. The extra drag could cause this junk to fall into orbit and burn up. Another potentially positive effect for Earthlings living closer to the equator is the increased visibility of aurora. Northern lights and southern lights are caused when solar particles enter the atmosphere and collide with gas particles. This usually happens at the poles, where the magnetic field is weaker. But during solar flares, more of the particles make it through the atmosphere. These opportunities will only increase as we approach a period of solar maximum, which is when we see the greatest period of solar activity every 11 years or so. The next few years should be really exciting because we will have a lot more chances to see the aurora. This might also be a likely time for another big solar flare to strike. According to Halford, it'll be a chance to see how well our safety measures and precautions can deal with this influx of solar particles. But don't hold your breath. A study published in 2019 found the chance of a Carrington-like event occurring before 2029 is less than 1.9%. Thus, as Halford says, a Carrington event is one of those kinds of things that you kind of want to have happen because we think we can weather it. As a piece of good news, the lead scientist for NASA's Perseverance Mars rover is excited about material that has been stored in the rover's sample tubes, both dropped on the surface of Mars and contained within the rover itself while wheeling about within Jezero crater. Given the samples of Mars that Perseverance has collected so far, could one of those specimens be what the rover was sent to look for in the first place? Evidence of past microbial life on the red planet? The preliminary finding heightens the need for returning these Mars samples to Earth so that these prized collectibles from the red planet can be sent to laboratories for more rigorous analysis. Caltech's Kenneth Farley, project scientist for NASA's Perseverance Mars rover program, briefed the Extraterrestrial Materials Analysis Group, or XMAG, during a meeting held May 13th of 15 in Houston, Texas. Tagged Lefroy Bay, Farley called attention to this sample collected by the Perseverance rover, found to have hydrated silica. Here on Earth, that mineral has the highest potential to preserve signs of ancient life. According to Farley, the Lefroy Bay sample and two other samples from the same unit, the Margin unit, are on board Perseverance. The Margin unit samples have abundant carbonate and silica, clearly indicating a dominant role for liquid water in their formation. But whether that water was surface water in a lake or river or groundwater remains uncertain. Either could constitute an ancient, greater than 3.4 billion years old, habitable Martian environment. These samples host phases that on Earth are very useful for establishing paleo-environmental conditions, and they can also preserve biosignatures. As such, these samples are uniquely important for return to Earth for further study. Perseverance is just about to make a really fundamental transition in the exploration of the environment that we have been working in, Farley explained in his briefing to the XMAG. One of the challenges they face this is not a great terrain for driving a rover across. So far, the Mars machinery has traversed some 27 kilometers after it was lowered to the area by Skycrane on February 18, 2021. The robot's objective is set in stone: seek signs of ancient life and collect samples of rock and regolith for possible Earth return. But why was the 45-kilometer-wide Jezero crater picked as the reconnoitering spot for the rover? Scientists believe the area was once flooded with water and was home to an ancient river delta. The anticipation is that Jezero crater is quite literally spilling the beans about its on-again, off-again nature of the wet past of Mars. More than 3.5 billion years ago, river channels spilled over the crater wall and created a lake. What's possible is that microbial life could have lived in Jezero during one or more of those wet periods. If true, evidence of leftovers from those little critters might be discovered in lake bed or shoreline sediments. The rover was dispatched to Mars with 38 tubes that could be used for rock, regolith, and even atmospheric sampling. And now, we're about 2/3 of the way through the sample collection. The on-duty robot has sampled igneous rocks, mudstone, sandstone, pebble conglomerate, carbonate silica olivine, as well as topside Mars sand, and snagged a whiff of Martian atmosphere. Earlier, in its trekking of Mars, Perseverance dropped 10 sealed sample tubes at a depot location dubbed Three Forks in Jezero crater. The intent is that a Mars sample return, MSR, mission in the future would pick up sample tubes for rocketing those bits and pieces of Mars to Earth. However, that joint NASA and European Space Agency undertaking is now going through a detailed relook due to a projected $11 billion price tag and an anticipated but not satisfactory time period to pull off such a complicated endeavor. Farley told the XMAG group that rover operators are working to qualify Perseverance to 90 kilometers of traverse, allowing it to make its way to enlivening landscape. Now, in the rover's travel itinerary is completing tasks at an area called Bright Angel, then move up onto the crater rim, where the rover can survey fundamentally different geology. In ascending the rim, this rover will expeditiously complete the sampling. The sooner Perseverance get the sampling done, the sooner scientists can all rest easy. That we have done our job. Another discovery. Astronomers have discovered an Earth-sized planet, orbiting an ultra-cool red dwarf star similar in size to Jupiter. The red dwarf, located some 55 light-years away, is 100 times less bright than the Sun and exhibits half the temperature of our star. This new extrasolar planet, or exoplanet, is named Speculus 3 and represents just the second time astronomers have discovered a planetary system around a red dwarf star, the first being the TRAPPIST-1 system. The Earth-sized world was discovered by the search for habitable planets eclipsing ultra-cool stars, Speculus project, located at the Paranal Observatory in the Atacama Desert of northern Chile. The aim of the mission, which is named after a popular Belgian biscuit called Speculus, is to use infrared observations to detect rocky exoplanets around nearby ultra-cool stars like red dwarfs and so-called failed stars, or brown dwarfs. According to Emmeline Beaumont, team member and assistant professor in the astronomy department at the UNIGI, Speculus 3b orbits a red dwarf star. The small size of these stars makes it easier to detect small Earth-sized planets around them, and above all, to observe any planetary atmospheres. Numerous studies show that life could develop on planets orbiting red dwarfs. They are, therefore, ideal candidates for us. While Speculus 3b is practically the same size as our planet, there are other differences that marks it out as radically different from Earth. This includes the fact a full orbit of its star, and thus a year on Speculus 3b, lasts just 17 hours. This exoplanet is also likely tidally locked to its star, meaning it has an eternal day side and an everlasting night side. We believe that the planet rotates synchronously, so that the same side, called the day side, always faces the star, just like the moon does for the Earth, Speculus team leader Michael Gillen said in a statement. On the other hand, the night side hand would be locked in endless darkness. Red dwarfs, or M-dwarfs, are believed to account for 70% of the stars in the Milky Way galaxy. Because they are thousands of degrees cooler than the Sun, they burn through their fuel supplies needed for nuclear fusion relatively slowly. This means red dwarfs have exceptionally long lifetimes, at least 100 times longer than the estimated 10 billion year lifetime of the Sun. The planet's star, Speculus, is actually part of an even cooler subclass of red dwarfs that astronomers predict will be the last stars alight in an eventually cold and dark cosmos. These orbs will likely burn for more than 100 billion years. This means life may have more time to develop around red dwarfs than it does in systems around stars that live fast and die young. However, red dwarfs aren't very well understood because of their low luminosity. Additionally, it is rare to discover planets around these small, cool stars. So, although red dwarf exoplanets might technically be the most common worlds in our galaxy, we don't actually know much about them. Speculus aims to change that. That fact that ultra-cool dwarf stars are scattered across the sky means scientists must observe the objects one at a time and over a period of weeks in order to detect possible transiting planets. That requires a dedicated network of professional telescopes like those that comprise Speculus, and the discovery of Speculus 3b marks a step in the right direction toward the goal of understanding red dwarf worlds. However, though red dwarf orbiting planets are touted as ideal locations for life to take hold, Speculus 3b isn't habitable, to be clear. The planet is bombarded by about 16 times more radiation than Earth receives from the Sun, making liquid water unable to exist on its surface. When it comes to hunting for life on a planet around a red dwarf, the 7 Earth-like planets of the TRAPPIST-1 system, many of which are in the habitable zone of their star, are still better targets. But this doesn't make Speculoos 3b uninteresting. Far from it. Speculoos 3b will be the ideal target for the James Webb Space Telescope, JWST, when it comes to testing if planets that exist in close proximity to their stars can hold on to an atmosphere. And if we find one on this highly irradiated planet, it gives us good hope that one also exists on the planets in TRAPPIST-1's habitable zone. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.